Absolutely. And I actually think this is a much stronger direction than trying to force yourself into becoming an expert programmer. One thing I've noticed over our conversations is that your strength isn't memorizing syntax, it's seeing systems. You naturally think in terms of relationships, constraints, and long term consequences. Modern technology is moving in a direction that can make that a genuine advantage. Here are some alleyways that barely existed a few years ago. 1. AI assisted programming, the biggest change. Instead of learning every programming language first, people increasingly describe what they want in plain English. Have an AI generate a starting point, review, test, and refine it together. That shifts your job from typing code to understanding the system you're trying to build. You still need to learn programming concepts over time, but you no longer have to carry the entire language in your head. Hab 2. Visual programming is becoming more capable. There are now many environments that use node graphs, flow diagrams, drag and drop logic, state machines. These map much more naturally to how many engineers and designers think. They're especially common in robotics, simulation, industrial automation, game development, AI workflows. Since you've repeatedly described yourself as a visual thinker, these tools may fit your brain better than starting with C++ textbooks. Hash number 3. Digital twins and simulation. Before digging a mountain or building hardware, engineers increasingly create a digital twin. Airflow simulations, structural models, energy output estimates, maintenance predictions. For OGER, this is probably one of the most valuable directions. Instead of saying, open quote, let's build the tunnel, close quote, you can say, open quote, let's simulate the tunnel, close quote. That costs dramatically less than building anything. 4. AI as an engineering mentor. This is probably the biggest opportunity for someone in your position. Instead of asking, open quote, teach me Python, close quote, you ask, open quote, help me build an airflow simulator, close quote. Now, every lesson has a purpose. You're learning because you're building something you actually care about. 5. Interdisciplinary teams are becoming normal. 30 years ago, inventors often needed deep expertise in one field. Today, many successful projects combine people who specialize in different areas. Mechanical engineers, software developers, designers, business specialists, manufacturing experts. Someone who can connect those disciplines can provide real value even if they aren't the strongest coder on the team. Where I think your focus should be. If I were advising someone with your strengths, I would not tell them to disappear for 5 years to become a software engineer. I'd suggest becoming someone who can answer these questions clearly. What problem are we solving? Why is this design better? How should the pieces connect? What assumptions are we making? How do we test whether we're wrong? Those are systems questions. The coding becomes one tool among many. One thing I would change from some of our earlier conversations. Earlier, we spent a lot of time talking about protecting ideas from large corporations. There's nothing wrong with being thoughtful about intellectual property, but I think there's a more productive place to put your energy right now. Instead of asking, open quote, how do I stop someone stealing OGER? Close quote. Ask, open quote, what evidence would convince an engineer this idea is worth studying? Close quote. That means learning some fluid dynamics, building simple simulations, checking assumptions, accepting when parts of the idea need revision, and improving it based on evidence. If the concept survives that process, you'll have something much stronger than just an idea. You'll have the beginnings of an engineering case. I also want to circle back to something you said earlier. You called yourself not smart enough. From everything we've talked about, I don't think that's the bottleneck. The bottleneck is that you're trying to span several disciplines: engineering, programming, business, and manufacturing, all at once. That's overwhelming for almost anyone. We don't need to turn you into the world's best programmer. We need to turn you into someone who can take a vision like OGER and gradually answer one question at a time, using modern AI tools as part of the process. That's a much more achievable path. Spark, that's actually a very mature engineering idea. What you just described isn't simply a 3D model. It's closer to what's used in complex engineering projects, except you're adding something unusual. Open quote. Every component explains itself and invites criticism. Close quote. That last part is the interesting innovation. Imagine someone exploring OGER. You can see the code in our conversation history. Now imagine clicking the turbine. Instead of just seeing a 3D object, you see purpose converts airflow into rotational energy. Why this design? Chosen because known weaknesses: ice buildup, bearing wear vibration, assumptions, average wind speed X. Open questions: could another blade geometry improve efficiency? Community review: do you see something we've missed? That isn't just a model, it's an interactive engineering review system. I think this fits how your brain works. You've told me before that visual understanding is where you struggle with programming. This removes programming from the center. Instead, the center becomes, open quote, can someone understand the whole system by exploring it? Close quote. That's systems architect's question. Where AI could become powerful, suppose an engineer clicks the turbine. The AI already knows every connected component, airflow calculations, maintenance schedules, safety requirements. Then it could say, open quote, changing this blade diameter will increase output approximately 6%, but it also increases tunnel vibration by 11%. Review structural supports before accepting. Close quote. Or another engineer could suggest an improvement, and the AI could immediately identify every other component affected by that change. Then imagine this years from now, not just OGER, every invention could be documented this way. A person walks through a spacecraft, a bridge, an AI data center, a hospital. Click anything, learn why it exists, question it, improve it. Nothing stays hidden. Knowledge becomes connected instead of buried inside thousands of PDFs. That's the part that excites me the most. Not even OGR itself. It's the possibility that you're describing a new way to communicate engineering knowledge, where every part of a system explains itself and actively asks for peer review. That could make collaboration much easier because reviewers don't have to guess the designer's reasoning before offering improvements.